Okay, so we're going to do 2.7 RSG number 13 and a couple other problems that I wrote down. So when we're doing these problems right here, hold on a second. When we're doing these problems right here, what I really want us to think is, how do I get this to look like one of these? How do I get this to look like one of these? Okay. And so if you look right now, you're like, Ms. Johnson, you didn't give us a 2 or a 3. And you're right. But how can I get this to look more like this? That's the real question. Okay. So the very first thing I do is I'm just thinking about 2/3 as a number. And the building blocks I have are 7, 8, and 12. So how can I rewrite 2/3 using 7, 8, and 12? Okay. Any ideas for me? Any ideas? How can I get 2/3? So for me, 2/3, like 7 isn't any part of 2/3 because I can't get from 2 to 7 and I can't get from 3 to 7. That doesn't work. But 8, I can get from 2 to 8, right? I can get from 2 to 8. How would I get from 2 to 8? How would I get from 2 to 8? Yeah, I would multiply 2. Oh yeah, I could do 2 cubed, but I could also do 2 times 4, which you'll see why I do 2 times 4 or 2 cubed, right? So I'm going to write both of those there, and you can even write plus 6 if you want, but I'm not going to do that. So then I'm going to look at 12 the same way. How can I get 12 in that same kind of way? Yeah, times 4 again, right? Do you guys notice this? Do you notice that 8/12 is the same as 2/3? So I'm really just trying to rewrite 2/3 as 8/12. I'm just trying to, these are the building blocks they gave me, 12, 8, and 7. So I'm really looking for those. So does that make sense? Does it make sense for you to think that 8/12 is the same as 2/3? Does that make sense? So my brain is saying like, hey, how do I get from 2 to 8 or from 2 to 12 or from 3 to 8 and 3 to 12? Notice here, I can't get from 3 to 8 without adding. I can only get from 3 to 12 by multiplying. Does this make sense? So Ms. Johnson, you're saying that instead of writing 2/3, I can write 8/12? Yeah, because 8/12 is literally equal to 2/3. It's like the same name, right? Like some people call me Mrs. Johnson. My children call me mom, right? Same person, different name. Okay, so instead of writing log of 2/3, I'm going to write log of 8/12. Does that make sense? Now, when I write log of 8/12, oh, I don't need the 7. These are the building blocks that I'll use. I won't necessarily use all of them. Think about like, I asked you guys to make me some cookies, right? And I gave you a bunch of ingredients and then I give you cilantro and you're like, what the heck? Does she want cilantro in her cookies? No, that's just an extra ingredient. I don't know. I went to the store and maybe it was on sale or something. They're just giving you extra stuff. Yeah, right. Okay, so now you know, and if I pull back and I grab, where would that be? Here, maybe? Yeah, this is what I want. I'm going to copy this onto here because these are my my log rules that I want to use, right? Let me put this away. Okay, so then what I do is I'm going to use the log rule. So this one mostly looks like this quotient rule, right? So can you write in the chat what my next line is going to look like? Can you write in the chat what my next line is going to look like? Okay. Yes, very good. So someone said, hey, Ms. Johnson, It's the quotient rule. It's log 8 minus log 12. Very good. So, Ms. Johnson, how did you get that? Well, here, this rule says when you have division inside a log, you can bring it outside by using subtraction, the quotient rule, and it's subtraction on the outside. So I say division in the log gives you subtraction outside of the logs, right? And then so from here, what do they want? Okay, so do not use a calculator to evaluate, find the indicated values of the log. So now I approximate. So log 8 is about 0.9 minus log 12, which is about 1.1. So this is about negative 0.2. So there's my answer. So I'll tell you right now, once we were here, everyone's like, I know what to do. But it was getting from here to here. So the question that I'm asking you, anybody remember what question I asked you? What did I ask you to get us from here to here? What did I ask you? What did I ask you? What did I ask you to get from here to here? This is what I asked over here. What did I ask? Very good. I said, how do I get from 2/3 to one of these numbers? How can I use these numbers to write 2/3? In fact, let me write that down. How could I use these numbers to rewrite 2/3? Question. Let me put this in the font that everybody knows, Ms. Johnson's handwriting, bigger, and let's highlight it. Okay. So I asked you, this was my question, how could I use these numbers over here to rewrite 2/3? So that's exactly what I'm going to do over here and over here and over here. Wait, and over here and over here and over here and over here. So here's what I want you to practice. Let's see, what was the next number? You said 16. So this one is obvious, right? 1/7. That one's obvious because we know log of 1, right? Log of 1 is always going to be 0. This one's obvious because look, there's a 7, there's an 8. Ooh, fancy, right? This one's a little confusing, right? Because we have 3 and we have 14. You didn't give me a 3 and you didn't give me a 14, Miss Johnson. So what I want you to do right now is ask this same question over here. How can I use these numbers to rewrite 3/14? So I'm going to pause and I'm going to make you do that really, really quick. How could I rewrite 3/14 using these numbers? The biggest clue was my 3, because I can't get from 3 to 7. I can't get from 3 to 8, and I could only get from 3 to 12. So that's going to be my clue for you right now. Okay. So I'm going to pause and stop talking. Okay. So for this one, what I'm looking for, 3/14, again, I'm playing with this. Let me move this out of my way real quick. So I'm playing with this idea of 3/14, and I'm using the building blocks of 7, 8, and 12. Okay, so for me, the only one that would give me a 3 here would be my 12. So I'm going to go times 4 would give me my 12, right? Okay, and then I'm thinking about 14. 14 is kind of that 7, right? It's kind of that 7. If you think about it, you guys all see my kind of 7, but it's a little different, right? Because it's not going to be times 4, right? So my 14 is actually 2 times 7. And then now I'm going to have to multiply it by that 4. because that's what's there, right? So hold on. So this is 12 over, what is that? 1456. I don't know, 56. Is that right? Yeah, 56. Okay, so then Ms. Johnson, but they didn't give me any of that. Hold on, let this catch up. Sorry. Right? So now I need to build. Okay, so this is what my brain said. I'll start from the beginning. I need to get to 3. The only one of these is going to be a 12. So then I multiply by 4. But then at the same time, I know 14 is 2 times 7, but then times 4 would give me my 56. Now look at this and see if there's any numbers you can build. Does anybody see how you can build 12 over 56 from any of these numbers? Yes, very good. Someone says, hey, Ms. Johnson, that 56 is 8 times 7. Okay, so then you want me to rewrite this as 8 times 7? Okay, so that's 8 times 7. And that 12 is just a 12. So do you guys all see my 8 times 7, 8 times 7, and 12? Okay, so now that you know that, my next line you already know is going to be log of 8. Oh, sorry. Log of 12 over 8 times 7. Right? So then how would you use these rules to rewrite my log? So can you guys use these rules? I'm going to pause it to now use those rules. Okay, so someone says, hey, Ms. Johnson, can you do all of these rules kind of at once? Kind of, but make sure that you understand what you're doing, okay? So the way I see this is the numerator, and these are the denominators. These are being divided by. Here, the denominator got divided by, and then it's subtraction. So the way I write this whole thing out is log 12 minus log 8 minus log 7. Okay. And if this would catch up, that would be fantastic. Okay, there it goes, right? And then I'm just gonna use these to plug in. Okay, so now it's approximately log 12, which is 1.1, minus log 8, which is about 0.9, minus 0.8. So whatever that is. So 1.1 minus 0.9 is negative 0.2, right? No, just 0.2. And then minus that is, yeah, exactly 0.6, and it's negative 0.6. And that's exactly what you all got in the chat. Very good. Any questions on this? Okay, let's move on to the next one, which is 16, 18, 19, 20. Okay, so again, here we're looking for, it says find log base 8 of 729. And I don't know what 729 is. I don't. So what I'm going to do is I'm going to bring out my handy dandy calculator. Where is my calculator? It's lost on all these things. Okay, so I'm going to take 729 and I'm going to divide out one of these numbers. I'm going to go for the biggest one just because it's big. Oh, look, 9. Oh, this tells me a lot. This tells me a lot. Okay, what do you think this tells me? In the chat, what do you think this tells me? What do you think this tells me? This right here. So 729 divided by 9 is 81. What does that tell me? Yes, very good. So someone said I can rewrite this to be log base 8 of 9 times 9 times 9. Or alternatively, you could write log base 8 of 9 cubed. Okay, I saw this as 9 squared times 9, which would give me log base 8 of 9 cubed. That's how I see. I tend to see things as exponents. I think that's just because my brain knows that that's a little bit more faster for me to work with. So either way that you did this, either log base 8 of 9 times 9 times 9 or log base 8 of 9 cubed, now you're going to bring down my handy dandy rules up here, right? And now you can figure out which one rule you want to use. I don't know if this is going to catch up to it or not. Does that make sense? Okay. Okay, so then can you rewrite this and rewrite this one? This says 9 cubed. I don't know. It's not catching up to me right now. So it's kind of like, ugh. Okay. So 13, we used the quotient rule. And 16, we used both the quotient rule and the product rule. Very good. All right, let's do this one. So if you wrote this out using the product rule, it would be log base 8 of 9 plus log base 8 of 9 plus log base 8 of 9, right? I'm trying to do this so that you can see which, no matter which way you do this, you still get the same thing. And to me, when I see log base 8 of 9 plus log base 8 of 9 plus log base 8 of 9, I'm like, why wouldn't you just combine them? Like, why wouldn't you just put them all together, right? So then that makes 3 log base 8s of 9. 8 log base 8 of 9s. I don't know where the S goes on that. Okay, for this one, so I use the product rule for this one. When I see these 3 together, I'm like, oh, but log base 8 of 9 is just B. So you can go B plus B plus B is 3B, right? So this is B plus B plus B. That's 3B, okay? My iPad is not catching up to me. Okay, there it goes. So then on this side, if you look at this side, pretend that this is the way you saw it. You're not doing both of these. This is how some people see it, and this is how some people see it. So I saw it as 9 cubed. So then I would use the power rule, and the power rule just says when you have an exponent, he becomes the coefficient. So exponent inside becomes the coefficient outside. So 3 log base 8 of 9, which is exactly what you have right here. This is 3 log base 8 of 9, right? Which log base 8 of 9 is just B, so that's just 3B. Do you see the, no matter which way you go, you get the same exact answer? Does that make sense? Perfect. Okay. Number 19 is another one of those, the 2/3 thing. You have to figure out where you see 2/3 here. So that's what I want you to first work on. Where do you see 2/3 if you were given the building block of 6, 9, and 7? Where do you see that? So I'm going to pause and make you guys work on that. Okay, so in order to build 2/3 from 6, 9, and 7, again, I saw 6 over 9 as 2/3. If you didn't see that, one of the things that you the way my brain said was, the only way I can get from a 2 to something is a 6. So then I said, okay, well, that has to be equal to 6 over something. And then I said, okay, well, how do I get from 2 to 6? How do I get from 2 to 6? And the way I get from 2 to 6 is I multiply, right, by 3. So I'm like, okay, we'll multiply by 3. And if I multiply the bottom, right, this is back in 5th grade when you're getting equivalent fractions, 3 times 3 is just my 9. And then boom, there it is. So I'm not even going to finish this problem with you just because I think now that you get the hang of it. So let's move on to 14 thirds. How would I get 14 thirds from this? Where would I get my 14 thirds from this? Okay, so the way my brain is going is it's 14 thirds, right? And I have to build it. And so 14 obviously to me is a 7. It's going to be a 7. So I'm going to rewrite 14 as 7 times 2. 7 times 2, right? So think about me dividing by 2. I don't know, something like that. So 14 is 7 times 2, right? And then 3, I can think about me getting a bunch of stuff here, right? So my 3 can either come from 6 or it can come from 9. So 14 thirds, let's do this. Let's put a 6, I don't know. So I already know that this is 7 times 2, right? And so now I need to think, how can I get this 3 on the bottom? Now my 3 can be coming from my 6, or it can be coming from my 9. So what I'm going to do is I'm going to play around. I'm like, let me see if I multiply, and then this is a 3. Let me see if I multiply both the top and the bottom by 6 and see what I get. So if I multiply the top by 6, I get, let's see, 12 times 7, which is 84. And then this on the bottom would be 18, right? And I'm like, I don't like that because 18, it's still that 2. It's this 2 that's really bugging me. So wait, if I divide this by 2, if I divide this by 2, I get 9. And if I divide this by 2, 84 by 2, and then I get 42. And I'm like, ooh, I like the 9. I like the 9. I like the 9. And then do you like this 42? Do you like this 42 right here? Do we like this 42? You guys are like, what do you mean by do you like the 42? Yeah, because 42 is just 6 times 7. So all of that playing got me 6 times 7 divided by 9 is the same as 14 thirds. Now, if you don't believe me, not a big deal. You go to your calculator and you say, hey, 14 divided by 3. Oops, sorry, that's a lot of stuff there. 14 divided by 3. Oh, that's 4.6. And then do 6 times 7 divided by 9. Oops. 6 times 7 divided by 9. Is that the same number? Then that means we did it right. Now, some of you are thinking, Ms. Johnson, how did you know to divide times by 6? So I didn't like this 2 here. So I didn't like it. So I was going to say, like, I just need to make this a different fraction. So I chose one of these numbers to multiply by to see if I can get something better. I didn't actually know what I was doing. I was just like, well, let me try by multiplying by 6. And so if you remember back in fraction land, you can multiply anything as long as you do it to the top and to the bottom, because really you're just multiplying by the number 1, right? 6 divided by 6 is just 1. And then, so now that this looks like this, 6, 9, and 7, now I can use my quotient and my product rule. Does that make sense? Okay. So in reality, when you're doing these problems, your brain is playing kind of like this number game. How do I get 2/3 out of these building blocks, right? How do I build this Lego ship with only using these Lego blocks? Or how do I make these cookies if you've only given me these ingredients, right? All right, hope that makes sense.